Does this work? All good?
For the camera, so talk with your voice to the room.
Okay. Hi, I'm Leonard Pottering. How much time do you actually have?
You are on for 55 minutes.
50? Wow, that's good. Excellent. So just to make this clear, if you have any questions, let's do that right away. Let's not wait until the end so that we can get a conversation happening here. I'm much more interested in leading the discussion into the direction that you wanted, and much less into me actually covering all my slides, because I know that I have too many slides anyway, and it's really about the discussion, not about the slides. Anyway, so yeah, today I'm talking about the Reinventing Home Directories. By the way, if any one of you has seen my talk about this very topic at All Systems Go or at DevConf, it's going to be the same thing. There's a huge queue there. If you have seen it already, it would be good to just leave and let people do it. You're not going to learn much new stuff. Anyway, but apparently no one has seen it before. Okay. So yeah, what I'm going to talk about is $home, right, as you know it, or tilde, as you can even call it more briefly. What is actually $home? $home is obviously a directory, as you know, right? But it's more than that. Like you always, for something to be a home directory, you also need a matching entry in etc passwd, actually in etc shadow, and these kind of things. So it's currently, two things. Like it's a user account in etc passwd, and it's actually a home directory in /home. There are many problems that I have always seen with this idea. First of all, it needs a writable etc, right? And where writable etc, by that I mean that if you create a user, etc needs to be writable. I personally think we should go towards systems where etc is generally not writable, except if actually reconfiguration takes place. And I would claim that creating users and things like that, changing users, is not a configuration change, but it's more like a payload change, right? It's what you do with the system itself, like what you do on the top of the system. It's not reconfiguration how the system itself behaves. So yeah, I think that's kind of weird mix right now in etc between the actual state, which is if a user exists or not to me, and the configuration of the system, which is everything else that tends to be in etc. So another problem I always saw is that we always have to, on Unix, propagate the UID assignments between systems. If you have like an NFS LDAP setup, it's like madness to deal with that, right? Like because the UID range is relatively small, and hence we need to be very, very careful if a system can show up in some environment that the UID is matched, because that's how we do access control and everything's messy. In the world of like with LDAP and with NIST before it and all these things, it's a major pain, and with NFS to keep these UID things in sync. I personally think, for most cases, how people use computers these days, right? Like, for example, how I use my laptop, this is kind of weird, right? Like, because we do all this infrastructure for propagating, but I think we shouldn't, right? Like, I think it would be way better if the UID would actually be an artifact of the local system. That only makes sense by binding some user record to the local system when we actually come up with the UID. That doesn't mean it has to be that way exclusively. It just means that I think we should go to that way where the UID is more the local artifact and not something global that we are supposed to propagate that actually isn't global, because, of course, these fixed UID assignments don't work outside of specific organizations. Another big problem that I see is that there's no encryption built into this, right? Like your home directory is generally not encrypted. You can have encryption on the disk itself, like distributions tend to do full disk encryption or do encryption of /home, but that's very distinct from the actual encryption of the home directory, which doesn't generally exist. And that is weird, because it has this, like if you do full description, I tend to use that on my laptop, and most people probably here in the room also do the same thing. You have this weird thing that during boot up, you actually query it for a password, and that's the password that matters, right? Like that's the password that actually protects the data. But it's a system password, and what the fuck's the system password? It's something like on Unix, which was supposed to be a multi-user system, the sharing passwords between multiple people is a very weird concept, right? So, and then after you typed in that password where that actually mattered, you got to user authentication to GDM or your Getty or whatever you want to log into, where we ask for a username and a password. And this password doesn't matter much, right? Like at that point, the data is all unlocked, right? Like it's just about access control at that point anymore, not about actually protecting the data. And this is really weird, right? Like first, the important one that is like on a multi-user system makes not much philosophical, like conceptual sense. And then the per user one which actually doesn't protect your data, which just does access control, but it's the one that actually is inherently the multi-user stuff. So, yeah, this kind of weird.
Yeah, to be precise, it's no user-controlled encryption.
Yeah, it's no. Yeah, exactly. I mean, it's system-controlled encryption. It's not user-controlled encryption, and that is like I don't think we should do things this way, right? Like because yes, most of the time our laptops are single-user systems, but I think still it should be. We should figure out how to encrypt the stuff, how to lock the stuff to the actual credentials you want to lock them to, right? Like the system, for example, should be locked to the TPM. But your data should be locked to something that you control, your password, your YubiKey, or something like that. Yeah, so I call that mismatching encryption, right? It's you protect your data with it, but actually what you protect the data with is a system property, not a user property. There's also the problem, no modern authentication mechanisms. By that I mean, like, we live in a world now where YubiKeys become a thing, but everything's bound still to one single password in Etsy PassWD. Now, people have retrofitted YubiKeys into this, but it's always a little bit messy because it does not live in the actual user record. It's not part of Etsy PassWD, Etsy Shadow. It's part of something like a sidecar database, right? So the inherent user database design of Unix is around passwords and nothing else, right? So, yeah, no modern authentication mechanisms. And we live in a world now where we probably want even more than YubiKeys and passwords. We probably want pattern authentication, face unlocking, fingerprint stuff. I don't care. But, yeah. So we're kind of stuck in this world there, which is very weird. It's also not extensible, right? And this is a big one, actually, I think. Right now, struct PassWD defines the same way as it was in 1985, right? You have these 5 fields: username, user ID, group ID, real name, home directory, and shell. Okay, that's 6. But it's beyond that, you don't get anything, right? You can't add a field there. It doesn't exist. People have, of course, always wanted to extend this. And they did, right? Like Etsy Shadow is like the first attempt to extend this. So they added an encrypted password, and they added some account meta information like how long is an account valid and things like that. But it's, yeah, and then you gain, I call them sidecar databases because they are managed independently of Etsy PassWD and carry additional information. These things get out of sync because, I mean, AdUser, for example, doesn't care about, I don't know, the SSH key, for example, because the SSH key, like in your home directory authorized keys file, that's a sidecar database, right? Like it's extending the user record in a way without actually having to get rid of the user record, right? So all these things, then they get out of sync, and they are messy. And if you do resource limits, for example, you suddenly have a completely different configuration format, like pem-rlimits.conf for these things. So, which is inherently user information, like how resources you actually want to give the user. But yeah, plenty of side databases here. Etsy Shadow is one. Accounts daemon is like this GNOME thing that adds information about like a photo to the user and a couple of other things. That's like the perfect sidecar database because it actually takes the Unix stuff and in a somewhat GNOME-specific way tries to add all kinds of newer shit to it. There's Samba, which maintains like a database for the SID, the SID, which is like how Windows does user management. SSH has the SSH keys, PAM limits does resource limits and things like that. And there's so much more than this. There's no resource management. Like the only resource management you get is PAM limits. But what they said, like resource management, I basically mean that, yeah, if we actually have a multi-user system, right, you probably want to assign a set of resources to specific users, right? Like because not all users are equal. The administrator probably should get more memory and CPU if he wants to, or she wants to, than a regular user. Right, so in a classic model, there's no resource management built in. The only resource management you get is PAM limits, and that's bullshit, quite frankly, because that resource limit is per process, right? So you can fork, you get a new set of resources fresh for free, and nobody will stop you from doing this. So how we actually want to do resource management these days is with C groups, the kind of stuff that System manages, and we have nothing so far. So these are the problems I always saw. And it's kind of, yeah, if you start doing something like HomeD and you figure out, what do you actually want to fix? This is stuff we want to fix. What we put the focus on is, then you have to figure out what's the focus actually. Yeah, you want to, like, who you actually want to use this stuff. The focus for HomeD is human users, right? This is in contrast to system users, like, I don't know, this user that your Apache daemon runs under or things like that. So for home, they only care about human users, like me using that thing. In particular, laptop users, right? Like this is a world. On a laptop, you usually have one user, maybe you have two users because your girlfriend uses it too, or your boyfriend, or whoever. But you're unlikely going to have 1,000 users on this one laptop, right? I mean, there's certainly environments which do that, but it's out of the scope for what I care about. So, yeah, the amount of users you have on your laptop is below 10. It's kind of the focus. The goals that I want to solve it the same way, because I kind of like this, is one of them. I'm not sure how much, how interesting this particular facet of this in real life, but I kind of found it a sexy idea, which is truly migratable home directories, right? All the way to the point of having a home on a stick. By home on a stick, I mean basically that you have a USB stick, and that this not only is where you store your home directory, but it is your home directory, meaning that you can plug it into this laptop today, log in and just works, and you can take it out and put it in another laptop tomorrow, log in there, and it all just works, right? So for me, migratable home directories means you have the actual data, but you also have the accounts information for that home record, all in one unified place, so they can just take it from this system into another system, right? So again, this USB stick thing, nice thing, and I'm pretty sure some security paranoid people will love this, because it basically means you never leave actual payload data on the system while you're logged out, because you just have it in your pocket and take it to the other device, and only then you log in there. But in general, like, I'm pretty sure, like, I personally wouldn't use this. Like, I want to store my data on my laptop because everything else is just, I don't know. I'm a lazy person. But it still is kind of useful that if I get a new laptop, I can just take this one file, which is my home directory, and put it somewhere else, and it's all in there. I don't have to reallocate the same UID and assign etc passwd in there, and don't have to populate all this other sidecar databases, so it all matches again with my old laptop.
So a very stupid security question. Because we are bringing our home directory to some random machine, then how do we protect the home directory we connected to some malicious machine that someone has root account and can just copy the content of our home directory, even though it was encrypted, but at the time when we logged in, it was decrypted.
So I'm not sure if I understood the question, but I'm supposed to repeat it. So the question was regarding how is this protected, that if you copy it to some rogue machine that...
So you take a pen drive from one laptop
to another
one, which is untrusted,
okay,
and has some malicious software, so as soon as you log in and unlock the pen drive, decrypt it.
So the question is, like, if you actually have your home directory on a pen drive and you move it from one machine to the other and you don't trust the other one, how does your data get prepared? It doesn't, right? The answer to this is, I mean, don't do that to untrusted systems. I mean, what do you think? Like, I mean, the point is really, like, of course, you have to establish some level of trust between your home directory and the user, right? And we do this to some point. Like, we, for example, all the, like, when Home manages something, it signs the user records and makes sure that you have to have a signed record that actually has a key in the key ring that is on that specific system to do the other kind of protection. But inherently, you know, the USB stick cannot, like, it's a passive storage, right? Like, it cannot enforce security policies on its own because it's not a computer. It's a storage device, right? So if the host has access to your credentials so that it can unlock your USB storage, right? If you were dumb enough to provide your password to that user, then it's freedom. Like, the system can do whatever it wants, right? But the key of what I'm trying to design here really is that you have very clear life cycles, that you basically say, when you're logged out, you're logged out. When you're logged in, you're logged in, right? And while you're logged in, you will get, or the system will get access to the device. But when you're logged out, it should not be possible to access your device, right? So that the moment where you decide to trust that machine, right, is the moment where you type in your password, and only then the machine can access it. And then when you pull it out, it loses the ability to do this. But yes, do not plug this into untrusted machines. If you do, you're dumb. I'm sorry. So yeah.
How to convince the user and make sure that they are aware that even though they have all their data on the pen drive, they cannot go just to the library and connect it to some random PC, because come on,
yeah,
I have all
I mean,
my data, I have all my home directory, I
this talk is not about fixing the problem of untrusted computers, right? I think we should do this better, and there is like Chromebooks, for example, have a better model there, not a perfect model, but I'm like, you know, you can never have an entirely secure system because sure, we can lock things down in software, and we should, but also, I don't know, I'm not capable of detecting a keylogger on my machine, like a physical one, right? So, I don't know, yeah, if you don't trust the machine, don't use it, but what I'm trying to get to here, right, is at least that it is very clearly defined, like when data access is allowed and when it stops, right? So that, yeah, the only thing that the user has to do is like provide the password to the system, and that actually and truly unlocks access to it. So, yeah. Anyway, let's...
80% of your problems are solved with using ZFS already. So why you never looked at it? For home directories, encryption.
I'm sorry.
Snapshot is there. Is there. You can move to ARM, to Spark, to other architectures. So,
yeah, I don't think that ZFS solves any of these problems. Like, first of all, like, again, home directories for me is something that's self-describing, right? Like, so you have the data store and you have the user record metadata. I don't think ZFS does that. ZFS is a user manager that has, like, a user database in it.
Your file system, your home directory.
Again, that's not what I'm saying. Anyway, let's have the discussion otherwise. I think this is like, this is about user management. ZFS is not a user management daemon. It's a file system. And I'm not sure I have to have the discussion here about what the difference between a file system and a user manager is. So I'm sorry, but let's discuss it afterwards.
Are you going to cover how to deal with configuration and caches residing in home and the version mismatch on one system with the other system?
Yeah, I mean, there's a general problem that configuration files are not always as stable as we wish them to be, but no, that's not in focus for this stuff. I mean, it's like, yeah, if apps break like this, it's nasty, but I think, you know, it's for the apps to fix, and it's I don't think, I mean, the big thing that tends to break is usually the downgrades, not the upgrades, right? Like, because app developers have an interest that the stuff just continues to work as people update the stuff. But I think the problem becomes less of a problem as soon as we move to a model where software is always updated, because we have to move to that model for security reasons, right? And then this kind of solved as a side effect, I think.
I mostly see the problem if you're going from a rolling release distro and have your stable release at work. And
yeah, but it,
you always have to handle with
it's kind of, you know, this is not a problem that is new to this model, right? It's a problem that you always had to deal with at NFS and these kind of things, right? But yes, you're expected to run the newest stuff in a world where we have security problems, and yeah. Anyway, let's go on with the slides for a moment. So yeah, the home directories shall be self-contained, right? Like, the data shall not be distributed over the entire system. There shouldn't be an etc passw entry, etc shadow entry, and all this sidecar database. It should just be monopolized in one place. And that also means that the mere existence of the file home foobar.home synthesizes the user record, right? So you drop it in there, and that's sufficient, so that get and passwd, like this Unix tool that allows you to, or Linux tool that allows you to enumerate all users, make sure that the user shows up, right? So, yeah, I mean, in a way, it's the most Unixy thing you can do. Everything's a file, right? Like, and suddenly the user becomes a file, and in this self-contained. I kind of mentioned this already, that I want that UAD assignments become a local artifact, right? Like, so that at the moment where you log in, the UAD gets assigned, and it's valid for this local system, but when you move the home directory to another system, then ideally you get the same UAD, but it actually doesn't really matter. If it's taken there already, you get a different one. And we deal with this nicely. So yeah, UIDs become local artifacts. It doesn't mean they have to become that. If you actually want to have a fixed one, lock yourself out, it's all supported. But at least it should be supported, and it should be the default of behavior, that people don't have to think about synchronizing UIDs across the entire organization. This is kind of core of one of the ideas, that the unification between user password and encryption key. I kind of already indicated that earlier, that we have this current weird split where you have the password for the full disk encryption, which is actually the encryption key, and then you have the user password, which is distinct concept. I think this is wrong. Should be the same thing. If I can decrypt a home directory, this is the same thing to me as authentication. And authentication should always be the ability to decrypt the home directory, so that things actually are unified and people can actually understand this. Also, extensible user records, right? I talked so much about the sidecar database and how awful they are. Extensible user records basically mean that anyone can put anything in these user records. I don't have to care. We don't have to have like a set in stone set of fields, but the Samba people can add their SID. The, I don't know, Kerberos people can put their stuff in there, and whoever wants to put more stuff can do this. It should be truly extensible, and everybody can have their own fields depending on whoever they want to manage. Also, one important thing is, like, we live in a world these days where full disk encryption is used, but also in a world where people don't turn off their computers anymore. I don't. Like, I checked the uptime yesterday. It's like 50 days. I have not turned off my computer anymore. So the way how full disk encryption works so far is always that, yeah, during boot you supply the password, and then it stays in memory all the 50 days that I've been using this computer, right? Like, so if you manage to steal my laptop and manage to access my memory, which is not as hard as you might think, you'll find my decryption keys in memory and can then decrypt all my data. And that sucks, right? So what should we do? We should make sure that when you suspend the machine, this stuff is erased from memory first, right? So that if somebody steals my laptop while it's suspended, they still will not be able to access my laptop. It's really like as if you had a house and you would just put the key next to the door so that whoever wants to break in can just take the key and break in, right? So fixing this, like Lux always had a concept of suspending access and thus erasing the key so that this all works. But it was always extremely hard to implement in real life because if you do full disk encryption, the OS itself sits on the encrypted medium, right? So if you want to re-request the password from the user when the system comes back from resume, you need to ask the user for something, but it cannot be this OS itself because the OS itself sits on the encrypted medium, right? And that basically means that, yeah, if something's not paged in, you need to read from a hard disk you cannot read from because you haven't supplied the password yet, but you are the one who is supposed to ask for the password, so you deadlock and everything's shit. So we need to come to a world where we can do this safely, meaning that the infrastructure that asks for the password needs to be separate from the stuff that we actually lock down, where we flush out all the keys. Also, what is important to me is, like, it's not all passwords anymore, right? Like, in particular, I'm interested in PKCS11 devices, like YubiKey specifically, but also any kind of other device where we actually truly use them properly, right? Not for authentication, not just for authentication, but also for the encryption part, right? So that we use them as the smart cards that they are, and actually derives the encryption keys for the Lux medium directly from the YubiKeys the correct way. So yeah, it's kind of key that, yeah, I don't know. I want to be able to use YubiKeys at least and actually not just use them for, I don't know, authenticating to Google. I actually want to use them to properly and securely protect my local system. So, there are a couple of complications with this. SSH logins is one of them. Like, the problem is always, like, if we lock this down properly, so that unless you have provided your password, it's impossible to access your data, you lose SSH logins to some point, right? Because SSH, you know how it works, right? Like, it reads the authorized keys file from your home directory. So before you logged in, how is it supposed to do that if the home directory is encrypted and you only can decrypt it after you authenticated? That thing is solvable, and we solve it to some point because we're actually able to embed the authorized key stuff into the user record, which is available before you actually mount it. But then you still have the problem somewhere, if you log in for the first time, the password needs to be supplied, right? Like in authentication via SSH keys, like how people use SSH, means basically there's never a password actually exchanged, but we need that password to unlock the disk. In an ideal world, we could just fix it so that when you log in, first SSH does its own authentication, and we would then simply ask the user, hey, please provide the actual password so I can decrypt the hard disk for you. Fortunately, the way SSH and PAM and these things work, we can't really do this. It's not a big problem. I know in the previous times I did this talk, people really hung themselves up on this issue. I don't think it's much of a big problem. Like, first of all, it's about laptops. It's the stuff you log with SSH out of. It's not the stuff you typically log in. If you do it for emergency purposes, and I can live with that to some point. Also, you can always do this thing where you log into some other account that doesn't have these kind of protections, and then locally provide the password to unlock it. Like, there's a command for that, and just log out and then log in really, because as soon as it's unlocked once, the SSH works as it always worked, because then the password is applied, and then the home directory is mounted, and everything's good.
Just to make sure that we're on the same page, you mentioned that SSH keys are now part of the user record or anything, which means that they reside in plain text on that pen drive, right?
No.
No? Okay.
So the question was regarding what about these SSH authorized keys? If they are part of the user record, do they reside unencrypted on the pen drive? No, they don't. Like if you actually, again, don't hang yourself up on the pen drive. I made that as an example, but I don't want you to think that HomeD is about home directories and pen drives. You can do that, but let's forget about the pen drive thing. But no, we of course made sure that this doesn't happen. So the user record is actually stored 3 times per pen drive or loopback file. Once inside of the home directory, which is encrypted. Once in an encrypted form in the LUX header, which is entirely redundant. The only reason we do this is mostly because the kernel file system people made very clear that they are not interested in making sure that images, like file system images that you have that are rogue, cannot exploit the kernel when you mount them. Right? Like there is no fuzzing and these things taking place so that you can have rogue file systems and the kernel doesn't fuck up if it actually accesses them. So that basically means we always need to establish trust first, to some point at least, before we mount it. Right? And the way we do this is by decrypting first that user record that is on the USB stick, verifying that it's properly signed, that it's a user record that's actually supposed to log in, and only then we go into mounting, so that the minimal level of authentication is established. But anyway, this user record is encrypted, like the first one. And then there's a third one, which is actually copied onto the host the first time you log in, right? Because we still have to pin your user ID so that every time you come back, you get the same user ID. That's important because the way Unix works, if you have a file in some writable directory somewhere, we cannot recycle the UID right now. It's something we will also want to fix with sandboxing, but it's a separate story independent of this one. But anyway, so yeah, you basically end up with 3 copies. 2 on the stick, 1 on the system. We carefully made sure that when you lose your USB stick on the street, somebody else picks it up, that the only information that is actually leaked to that user is your username. Right? Like, because we need that, because if we stick it in, then you have to still type something into your Getty prompt or something. And then provide the password. And the password is, when you provide that for the first time, is actually the thing that unlocks the user record. Because again, as talked for earlier, we need to define clearly the point in time where this trust is established, where you provide the password to tell the system, it's okay now, you may have access, I trust you. Disk space assignments. So with HomeD, like the way HomeD is actually something that has 5 different backends. The backend that I try to push people towards is the LUX backend, where you basically either have your USB stick or you have a loopback file in /home, where everything is stored internally. But there are actually a couple of other backends. Like there's one for FSCrypt, which is like XD4 online, like the encryption that is above the file system layer. There is also a couple of others, like plain directories, even if you don't care about encryption. But the one that I actually think that people should be using is the LUX one, because it has the strongest security properties and allows you to do these things like erasing the keys from memory when you suspend and more things. But it comes at an interesting behavior, which is disk space assignment. If we have a loopback file for every user in /home, then it basically means, the disk, like how you size that loopback file basically means how much data that user can store, right? Traditionally on Unix, we always said that, on my laptop, if I have 5 users, all of them can fill up /home as they want. They all fight for the viable disk space, and the one who is lucky, and the one who isn't lucky is not lucky, right? With disk space assignment with loopback files, you of course have to size the stuff a priori. We can resize online all the time. That's great. That's exposed in HomeD. But you still have to, you basically get committed disk space assignments. And if you think about it in a simple way, they cannot overlap, right? So that basically you lose the overcommit functionality that how user management traditionally worked, where you basically would say, even if you use quota, you could say, I have a 1 gigabyte disk, but I give everybody 2 gigabytes of it, which made no sense, but you could do this, and was kind of how we did this thing. Right? So I don't think that's much of a problem, because we have these nice behaviors in HomeD, where you can do stuff like, sparse files and discard. Like on Unix, we have this concept of sparse files, where basically if you have a large file and it has zeros in it, you don't actually have to allocate space for these zeros, but you can just let the file system deal with it and tell it that this is empty space. You're not supposed to store it. Just when I read it, give me empty space, like zeros back. So, we can use it all across the stack, like that the loopback device does that and the file system device does that. And in HomeD, we have this automatism that when you log in, we actually allocate stuff for you so that actually this white space is removed. That basically means that while you're logged in, you get these guarantees that the 1 gigabyte you got assigned is actually what you get assigned. But when you log out, we tell basically the kernel to remove all the holes again, return it basically to the underlying file system so that somebody else who then logs in can use them. The effect of this is, we give you guarantees that when you log in and you are assigned 1 gigabyte, you get the 1 gigabyte and nobody can take that away from you. If you're logged out, everything is shrunk to the actual space that you need. And other people can use that space. So yes, disk space assignment becomes a little bit more complex, but it's actually, I think, very nicely manageable as long as you don't assume that you want multiple users to use your laptop at the same time. I'm not sure how that even would work because I only have one screen, one keyboard, but sure. So yeah, there's also the problem of UID assignments. And it sucks a bit, because as I mentioned, I want that the UIDs become artifact of the local system. And if they become artifact of the local system, we have to pick a UID at the first login and assign it to that user that is not used on that specific system yet. But that sucks because then all the files in the home directory will be owned by wherever this stuff was mounted earlier, where it got a possibly different UID. What do we deal with this? Ideally, we would just tell the kernel, mount this stuff and make all files owned by this UID. Unfortunately, the kernel currently doesn't have that. Hopefully, eventually it does. So what do? We do recursive chown, meaning that when you log in and the UID doesn't matter, we just actually go to the file system and chown all files. Sucks. Doesn't suck as much as you might think because actually choning recursively on modern file system is ridiculously fast. They're optimized for this kind of thing that Dentry lookups are cheap, and so it's not as slow as you might think. At least on my home directory with I don't know 500 gigabytes or something or more. It takes 2 seconds if the UID actually changes. Yeah, this comes up all the time. We can use user namespace for that, but actually I don't think we want to. User namespace basically means that you have to have a sandbox around the user because he has to live in that, or she has to live in that namespace. But that sucks because as soon as you do sandboxing, you basically lose privileges on the system. You live in your own little world. People have done this before, particularly for file system namespace, and I'm pretty sure we should go that way eventually. But it also means that, weird things happen, because if you do these kind of mount namespaces, then you see the system in a completely different way than you would traditionally do. With HomeD, I didn't want to go to that step yet, right? I think we should have sandboxing, but also this is inherently supposed to be something that I want to use on my laptop, right? And if my user can't see the system anymore the way it is, then I'm going to have a very hard time with debugging that stuff. But you're absolutely right. Eventually, we should have sandboxing, and I don't know, if I built a laptop like this and give that to my mother, she has no need to see all the processes owned by the correct users. So for her, we definitely want the sandboxing just work. Yeah, Lux locking, I already talked about this, about the stuff that, as mentioned, HomeD does this thing where when you suspend the system, all the crypto keys that are actually used for Lux stuff is removed from memory. But then we have the problem that when the system comes back again, we have to provide the passwords again so that you can actually use your home directory. The way we address this right now is we don't. We have this requirement basically that after you come back from resume, there's some kind of authentication taking place where we can read the password again from the user and use it to unlock stuff. The way I think how this should work in the end is that if, for example, if you use GNOME, that right now you get, when the system resumes again, you get this lock screen where you're supposed to re-authenticate, but this password always stays with the GNOME, and I think it's, and it runs this password prompt runs under the user ID of the user itself, which I think is problematic anyway. But that approach doesn't really work anymore because, after all, if we come back from the resume, everything that is in the home directory and that accesses the home directory is going to be suspended because we removed the key so that it can't actually read or write from that home directory. So what we do need to do there is that instead of doing the screen lock from the user's own session, we need to switch back to GDM or something, to the display manager, to some privileged component that asks for username and password. And then when you provide the password, we can use it to unlock everything, and then you can switch back. So this is a little bit of a complication, but talk to the GNOME people, I think they're very much on board with making this work. As long as we don't have that, you can even just switch to a Getty, do a quick login, log out again. And
okay, disable the plain media where you're logged to.
Sorry?
Like plain media where you're logged or access to some data you want. for example, Chrome shall introduce the ability to control your media, right? Your law that you want to continue to do that. Like media playing.
Media, like you mean music playing? Oh, well, I mean, it's like this stuff is supposed to be secure, right? Like so that you get this guarantee that when you're not sitting in front of the computer and have provided the password when you started using it, that nothing can access your home directory, right? Like, it's a security guarantee that I want to give you because I think it's a good security guarantee. This does conflict if people want to do stuff with, for example, that, I don't know, you get email notifications when you're not logged in and things like that, or that you can play music while you're not logged in. But, yeah, that is fine even, right? Like, in that case, don't suspend the machine. I mean, you wouldn't suspend the machine anyway, would you? Like, I mean, because then the music would stop playing too.
Okay, so that's only on suspend, nothing make it lock,
So...
Yeah, I want to expand on that. Like, I'm sending a big file to a server, waiting 2 hours. I'm going away because I need some coffee. I'm not going to sit there. I'm going to log out. Well then, I'm losing access? My download is not continuing?
Yes. I mean, I will give you the guarantee. So the question was regarding what happens if I do a long-term, like a long download, and you traditionally, this person here solved it like logging actually out and making sure that the download continues in the background. What does happen if this is used? Yeah, I'll give you the guarantee when you're not in front of the computer, your data is not accessed by the system, right? And this basically means it conflicts with that stuff. But, you know, you can, like, this is like, you know, this lingering concept of login. It basically allows you to say, yeah, leave this stuff around from this user when you're logged out. You can just turn this on, but that basically means you lose this nice property, because that means the crypto keys need to stay in memory as long as your stuff logs out, even you're not sitting in front of the computer. So yes, you can do this. I don't think that it's nice semantics though, right? I'm pretty sure that, at least for my laptop, I want to know that when I leave this stuff, that I know that nothing there can access my memory, that, I don't know, everybody can steal my laptop and still not get access to my memory. This is a much nicer property that I want to deliver to people than yeah, being able to download, finish downloads while I'm not logged in. So, yeah, I mean, this is conflicting stuff, right? I know, like, I mean, we take away to some point cron jobs for you as well, right? Like, because cron jobs traditionally had this thing where they would run even when you're not logged in, right? In this model, it does work, right? Like, if you run stuff as unprivileged user while you're not logged in, somebody has to provide the password, and if you don't, because you had less cron job, then no way. You don't get to go do this, right? But this is entirely up to you. You know, if you subscribed into this model, like actually using HomeD and getting these security ideas, you lose the property of being able to use your home directory with authentication. But then, if that is important to you, you probably shouldn't use HomeD. Or, like, I mean, there's something we can probably do is that if you turn on this lingering thing that I mentioned, right? And that basically also means that we can basically set up the user context during boot instead of during login, right? So we could actually say, if you set up things like that, and we need the password to actually work, that we ask you during boot, like we always did for full disk encryption, for the password, so you log it once at that point. But this is not implemented. This is something that's relatively easy to do, but we don't do that right now. But I don't know, it's kind of outside of the model I want to go to, right? I wanted this lockdown, secure thing. And that is, like, for me, means that if I'm not at my laptop, nothing should get access to my data. How much time do I actually still have? 17 minutes. So, actual implementation. I talked a lot about the stuff that I want to do with this. Now let's actually talk about how this translates to code. In systemd, we added 2 concepts, and all the last stuff was actually merged 2 days ago. One is JSON user records. JSON user records, like, with all the stuff I talked about, looks and the actual HomeD stuff is kind of independent of this. Like, the first thing I want to deliver is JSON user records. So basically that, yeah, a struct passwd, you can have that in JSON now, and it's fully extensible. And you can denote lots and lots of different properties. And systemd, if you provide these JSON user records, will actually do resource management for you, a couple of security things for you, a couple of like actually other runtime parameters for you. But we can agree on some form of more modern way of talking about users. These JSON user records are not bound to HomeD. Like, HomeD is one component that then makes use of this, but actually anyone can supply them. Like, anyone who's privileged on your system can provide additional JSON user records. And I we just had this conference, this DEF CONF conference in Czech Republic, like where I talked to all the Red Hat people who do LDAP and these things, and we're mostly on the same page that, yeah, they're going to supply from SSSD and this LDAP stuff user records in the same format, so that for the first time, they can, from the LDAP database, actually do proper user management, security management, that all the way proper guides done to the system, and systemd enforces it. So, yeah, this is concept A. As mentioned, independent of HOMED. You don't have to buy into HOMED to be able to make use of this. It's a superset of NSS records, so it's struct pass WD and struct group, and actually all the shadow ones, and extensible. There's a varlink interface. Varlink is some IPC system to query this, and it's extremely dumb and simple. And the idea basically is that anyone, like any component that wants to provide a local user, can just implement that varlink interface once, and then clients can just ask them all at the same time, and I'll query those users. It's convertible forth and back to an NSS, lossy of course, because NSS records, like by NSS records I mean like struct pass WD and struct group, because they of course don't have all the metadata. But systemd will do all the conversion for you, so it's up to you. If you just want to supply the classic NSS stuff, like most components currently do, then we'll generate JSON stuff on the fly. But the other way, we'll also do it. Like if you only supply the JSON stuff, then we'll generate NSS stuff for you if you want that. How does it actually look like? Here's an example. It's kind of complicated. Some things are pretty obvious, like username. Like this user is called Groby, and I don't know, nice level means that when the user logs in, he gets a nice level of 5. This member of is about groups, that this user is supposed to be a member of the group wheel. Last change USEC, I guess I don't have to explain what that probably means. There's a concept of certain subsections like binding, which is like the binding one is actually the one that maps a user record onto the local system. Right, like because a user record is something that I think should be independent of this, the local system, but some of its fields inherently, like for example the user ID, like this one here, actually inherently have to have a local concept if we want to do this thing where we say that UIDs should be a local artifact. So binding is supposed to manage this. Binding is basically, this is the machine ID of the specific system, and then you store a couple of metadata that is specific on that system to it. I don't want to go into too much detail about this. There's specification up if you want to know all this. Just to see that, like, privilege is basically where the hash password is. It's like Etsy Shadow. We put that in a separate section so that we can hide it from clients if they shall not have access. There's signature, which is like the cryptographic signature that I mentioned, how you can make sure that, on a specific system only, for example, users signed by the Red Hat key can log in and other systems not.
Do the users' names have to be unique in systems?
Very good question. So the question was regarding if usernames have to be unique on specific systems. Yes, they do, because Unix works that way. But that basically, like, so I added a concept called a realm there. It's a little bit more like a Kerberos realm, but it's also like domain. I didn't want to define that any further. But the idea basically is that I can have user Leonard at redhat.com and can distinguish it from a user Leonard at, I don't know, Berlin.de or something like this, because they have a different suffix. But once you log in on that specific system, only one user Leonard can exist. Right? So it's a bit nasty that this is how Unix works, and we can't really fix that. But I think it's probably in real life not that bad, because on my laptop I'm probably not going to have multiple Leonards that are actually different. So that was the first thing, user records in JSON. Second thing is concept B. That's actually the HOMED part about it. So we have encrypted LUKS home directories and loopback files, the stuff that I was talking about so long. I mentioned that we have one file per user, like /home foobar.home is a loopback file, a gigabyte in size. Inside of that, you have a log stuff. You can actually mount that thing just with regular tools like you always did, because it's just that, right? Like, it's not the reinvention of stuff. It's just using stuff we already have and augmenting it slightly bit so that it's useful for user records. If you mount it, you find the JSON record, like the actual user record inside of identity there. But yeah, it's managed by a new service called systemd HOMED. You can accept this and use it, or you don't have to. It's like entirely one provider of that user DB stuff, but it's just one provider. If you don't want to use it, don't use it, right? Like, there can be others. Like, for example, if you're really, really bought into the LDAP concept, that you have everything centralized and machines kind of part of an organization, if you so will, then you can soon, hopefully, use the user DB stuff, but not use HOMED. Like, HOMED is really about the use case where you have relatively migratable, independent little laptops. I have a user directory here, and I can migrate it to another one, and it all just works. Yeah, concept A, user DB records, is independent of concept B. in one way, right? Like you can use A without B, but B implies A. Yeah, integration with OS, a couple of other components, but I don't want to go into much detail here unless you have no further questions, because I think we have only 10 minutes left or something. So let's focus on questions.
No, so we just want to make sure. So does usage of HomeD discourages or even does not allow to lock screen without logging out, so that you lock the screen and you keep your processes running?
Sorry, what do you mean? I don't get it.
So as I understand, HomeD discourages or even prohibits to just lock the screen, but do not log out.
No, it doesn't.
Huh?
No.
Can you repeat the question?
So the question was regarding if, as you understood it, HomeD prohibits locking the screen without actually logging out. But that's not true, no.
Okay, so I just...
Screen locking is screen locking. But screen locking means, to me, that the keys are left over there. Like you can, if you want to, turn this into something where you say basically screen lock also means we flush out the keys. That basically means, yes, everything stops running. But we are not there yet. This is something we can think about, but I'm not sure if we want this, but if we do this, then it should be an option. But no, this does not imply this. This is something to think about that we might do later, but no implication there.
So you said that the idea is that you can migrate your home directory from one machine. What is the frequency you plan to do that? Is that a rare option? It just works? I personally work every day with 2 computers, and I would like to carry a pen drive. Is that something that is just done in a minute that I can somehow do that? And if there are several versions of that thing, that when you need backups, how do you do the versioning, and what happens if I start to use an older version and then I go to the newer one?
Okay, so the question was regarding synchronization, right? Like if you have multiple users, and I know you have the same user on multiple machines, like how do we solve this? We don't. Right, so this is not a synchronization tool, right? Like, I think having a synchronization tool would be extremely interesting, but it's, and I think this can actually be really nice because, like, I mean, as soon as you have your home directory in one unified file, you can do stuff like actually distributing it to other systems in encrypted fashion without actually the distributing thing actually knowing what it actually distributes there. You can do backups even, like, because you can do reflink, like, because it's one file, you just do a CP with a reflink, you pay for nothing, you have a backup of that day and things like that. So I think the synchronization problem is a very interesting one. We should look into this eventually, but this one is not going to solve this. And in particular, it's not going to deal with deltas for you, right? Like with diffs between what you did on this laptop and what you did on this laptop, because that is inherently something that needs to live above. Like if you actually want to do proper diffs above the file system, above the encryption, because I mean doing diffs on encrypted stuff isn't really possible. So I think a very interesting problem, not going to be solved by this, but I think it enables some things that we can make distributed stuff like this work. Like for example, that I don't know if you are connected with a network, that we just make sure that you're only logged in once everywhere, and then whenever you log into something, that your stuff migrates somewhere. I mean, you can even do stuff like, for example, you can have your home directory on an iSCSI volume or NBD volume or something like this, which is available onto your entire network, right? Because this stuff is just a fucking block device. It basically means that, yeah, if it's just there, it's going to pop up as a user, and then you look at any machine you like, and you know that it's always shared because you always write to the same thing. We have no infrastructure for locking in this case, so don't actually do this, but it's certainly an idea. Like it opens a lot of doors where you can do stuff like that. But yeah, syncing is not solved right now. But I think it's very like the other problem with syncing is like people disagree what they actually want to have synced. Some people want just the configuration. Some people want the entire home directory. I have no nice answer like to this. The GNU people have been looking into doing some syncing stuff. I don't know where this goes. But yeah, we have to figure that out.
I have a question about groups. In fact, if you have two laptops with different groups with the same name, with your first design, you can define a user with some groups, but if you use the common groups but with different what's happened?
With different what? With different?
You can have the same groups, but on both systems could be different rights.
So the question was regarding what happens if groups are defined differently on multiple systems, but you have one user that is accessing both of these systems. So first of all, you know, you saw the JSON stuff, right? Like there's actually a section in there. It's called per machine, where you can have static data that you configure, and then you can configure different, like of some of these settings, you can define per machine settings. So you could basically say, yeah, if on this laptop the group foobar is something completely conceptually different than the same named group foobar on some other system, then you can basically say, yeah, on this one I want to be a member of that, on that one I don't, right? So first of all, that's one thing. Ultimately, the rule though is we allow access to anyone who has a user record that is signed by some key that is recognized by the local system, right? The entity that signs that really needs to take care of this problem, right? So I'm not going to solve this problem that if you have equally named stuff on different systems for you, that's the person who puts together the user record for you who needs to deal with these problems and then maybe create per machine stuff or do something else so that this problem is fixed. Well, I mean, I'm not a standards organization. So what's the state of the standard for the JSON user records? I'm not a standards organization. I mean, I kind of am, but also I'm not. Let me show you. Yeah, there's lots of interesting stuff in the slides, by the way. That's where the standard is. So if you go to this one, this is where the current JSON stuff is documented for the users. This is for the groups. This is for the Varlink API to query it, and this is what it documents what we do if we use the logs home directory stuff. If you use that backend, yeah, all of this is extensible, right? And it's extensible in that fashion where you're not supposed to even talk to me if you want your own field. Just take it, just namespace it properly, right? I'm not interested in being like this person in the middle who manages everybody's fields. That's explicitly not what I want. Just pick a field you want, namespace it properly by just using a name that's unlikely to collide with everybody else's, and then add whatever you like. It's supposed to be distributed like Linux is, right? So, yeah.
We talk about security. Is there a threat model for only? Because for me it resembles FingerD.
Well, it resembles what?
It resembles FingerD.
FingerD?
Yeah.
Okay.
Which would give you access to the home directories.
So I don't really sure if I understand the question, but if we did a threat model of this kind of stuff, because it resembles FingerD, I don't understand why this would resemble.
FingerD would give access to other people to $home.project to show which projects you have, and it was flowed with that design.
I mean, I know what Finger is, but I don't see the relation to this. You know, Finger is not about user records, and it's not about, like, I mean, again, like, this stuff is, like, if we put it in the home directory, that stuff is encrypted, right? Like, we don't leak information. Unless you're logged in, nobody gets access to this. And this stuff is, so it's actually only accessible to people who have access to the system. They can query the user database because that's how Unix always worked, right? But at that point, you also already have to have access to the local system. So I don't know, if you want to implement something like FingerD on top of this, you can use this stuff, but I don't see the relationship to FingerD at all, I must say.
Because it gives you access to your own directory, just like on DDoS?
I don't see that, I'm sorry.
So how do I share a file between two users?
So the question was regarding how do I share files between two users. Well, you know, after both of them logged in, the users are not very distinct from traditional users, right? Like, they'll both have a UID that's going to be sticky until the system goes eventually.
When they log out and log in once again, you just change the owner of each
No,
and every file.
no. I do that when you do it on a different machine where the UID is actually different, right? Okay. So the question regarding, like, if you log out and log in again, what happens to the UID? Do we actually change it so that sharing files is difficult? So, like, first of all, you know, if you want to give other users access to your home directory, right, knock yourself out. But also, it's maybe not the best way to share files, right? So ultimately, like, on a specific system, after you logged in once, we copy the user record onto the system so that it stays pinned, and the UID assignment stays pinned. So that basically means that after you logged in once on a specific system, UID is stable, guaranteed to be stable forever, right? We can only remove that limitation if we do the sandboxing stuff that we talked about earlier here, right? Because we need to make sure that you don't get to write anywhere else. But that basically means, yeah, if you want to use ACLs or Chmod or Tone or whatever else to give other people access to your files, same way as it always worked. Except if you then take that home directory and move it to a different machine, because if you do that, then you get the choning done, but that also means that we'll strip all the ACLs for you. Because, I mean, we have to, because all the user ID assignments and things like that don't make sense anymore. If you then move it back to your system, you'll get back the user ID that you had before, but you'll not get the ACLs back because we had to strip them all. So, but my answer is if you subscribe to that traditional model, knock yourself out, but then you don't get the truly migratable stuff. It's one or the other, up to you.
So are we going to have any, let's say, a default folder separate for sharing files between users that reside on the machine and they're not encrypted or anything like that?
So the question, I mean, my time's over, but let's do this one last thing. The question is like, will we have a shared folder where you can actually share stuff between users? I mean, you can do this. Homely doesn't do this for you. I don't think. Like, you know, I'm pretty sure that in most cases, when you want to share something with other people, we probably do it via, I don't know, Telegram or email or something like this, because inherently it means probably most of the people you want to share stuff with are not going to use the same system. Like, at least when I have shared a file with somebody else in the last 2 years, 20 years, they didn't have access to my local system, right? So I think the focus for sharing stuff should always be on doing it distributed, right? Meaning do it on the network and not on the local stuff. But again, write that infrastructure if you want this. It's totally doable. It's totally doable already. Yeah. I think that's it. I don't have any further time. Thank you very much for your interest, for the questions. And, if you have any further questions, let's do that outside.